Hi, I'm going to do some short videos about volumes by cross-section. So if we look at some solids here, we've got a cylinder and a cross-section where I take a slice out of there in green, and you can see that the cross-section is a disk. It's got an area times the area pi r squared times delta H. And then if you look at the square pyramid and the triangular pyramid, I've got a cross-section cut out there where I have a V sub I, or that representative slice out of the pyramids. And we find the square pyramid by taking the S sub I squared times the width of that, or the thickness of that slice, which is delta X. And it could be delta anything, but it's delta X. And then V sub I is equal to 1/2 base times height for the triangular pyramid. And then we take and multiply by delta X. So with volumes by cross section, the first section we're going to work on is problems 1 through 3, where we have a square cross section, a rectangular cross section with a height of 2, and a semicircle. And then we're going to have a second video on 4, 5, and 6, and that would be having a square cross section perpendicular to the y-axis, a rectangular cross section with a height of 4, and then a right triangle cross section with one leg in the base that's colored in yellow, and then one leg is going upward. Okay, this was just an old file I had in, I call it my green apple file. I thought it was a kind of a clean cut way of going over some cross-section problems. So first problem is we're going to let the region be bounded by the equation x is equal to y squared and x equal to 9, and that's shaded in yellow. Find the volume of the solid that has r as its base, and if every cross-section by a plane is perpendicular to the x-axis and has the given shape. First of all, when the cross-section is perpendicular to an axis, then that cross-section has a thickness of delta x, okay? If it's perpendicular to the x-axis, I mean. So we need to have a dx here. The equations are given, but I need to have the equation then in terms of x's. So I need a function of x. In other words, when I set up the integral, I need to take the integral from a to b of the area dx, and the area has to be a of x. So I'm going to start off, I need a dx with respect to x. So the area of a square is, of course, s squared. And we need a side expression for s. So s is equal to s of x then, because area is equal to side squared. So if you notice, going from here, I turn my notifications off, forgot one thing, going from here to here, that's the distance, the square root of x. Probably should have chosen a different color, but from here to here, that's square root of x. And then if you notice, then over from here to here, it would be, by symmetry, it would be the same distance, so it's square root of x. So then the side has a measurement as a function of x as the square root of x plus the square root of x, just the side. So we get s of x is then equal to 2 square roots of x. And then remember, in our area formula, a of x, we need to have side squared, so we need s of x squared, which is then equal to 2 square roots of x squared. So we get an a of x that's equal to 4x. And then we're going to plug this into the integral. So we get the integral. And remember, the limits of integration are going to go, you integrate what's there, not the air. So we're going to start at 0, and we're only going to go to 9, because that's where we're going to stop the base area right here. So we have a of x, we're going to put in as 4x, and then we have our dx that comes down. So kind of a simple integral. So we get the volume is equal to 2x squared as we integrate 4x squared over 2. And then we're going to evaluate that from x is equal to 0 to 9. So we end up getting 2 times 9 squared minus 0 squared. And that's going to equal to 2 times 81, which is 162. Okay? All right, I may not go through all the integration. If it's a little bit longer, just to save time, you can do, most of these are pretty easy to integrate. But there's our first answer. Going on to the second problem, where we have the same function, same base area, but now our cross-section is a rectangle with height 2. So you see that the 2 is labeled here. I have it on both sides. Let me get a different color. So We have a 2 here, but I wrote it again over here on this side. So, and then I also put a rectangle down by the origin, so you can see that by the origin, our rectangles are going to be fairly small, and they get really small when they get to the origin. It's going to be 0. So the area of the rectangle, that is going to be 0. So I have the points listed as a point that varies on the function x square root of x, and then on the lower side, you have this negative square root of x. So it's the bottom part of the function. So we're only going to be using, for the area, the same one we did for problem number 1. We're going to just say that the base is then, area is equal to base times height. So the base in this case, the base is just going to be 2 square roots of x. And the height is, of course, 2. So in writing this, we're just going to write 2 square roots of x times 2, and then we're going to simplify the expression. A of x is equal to 4 square roots of x, or we could write that as 4 times, or 4x to the 1/2 power, since we're going to go ahead and integrate that anyhow. The limits would be the same. So we get the volume is equal to the integral from 0 to 9 of 4x to the 1/2 power dx. Once we have our integrand, we can go ahead and integrate now. So we have the volume is equal to 4x to the 3/2, adding 1 and then dividing by that same quantity over 3/2, and then we're going to evaluate that from x is equal to 0 to 9. So we get the volume is then equal to 8/3 x to the 3/2. So then that's going to be 8/3 times 9 to the 3/2 minus 8/3. Let me take the parenthesis out of there. And so that would be minus 0 to the 3/2 then, leaving the constant 8/3 out front. And so then that's going to be 8/3 times 9 to the 3/2 is going to be the square root of 9 cubed. So that would be 27. And simplifying that, 3's cancel, we have 9. So our final answer is 72. 72, and that would be units cubed, of course. We'll just leave the number here. Okay, that's the second problem. And then we have one more for the first video. We have a cross-section that's a circle. So then we're going to go right into this. We have the same base area. So we have the volume is equal to the integral from 0 to 9. And we need a formula for area. We know the area of a semicircle is pi r squared, pi r squared over 2. So with this, the area sub x that we need, area sub x is then we need an expression for r. So I'm just going to put this underneath here, what r is equal to. R is, remember, is equal to the square root of x. So we end up with pi, and I'm going to put the pi over 2 out front, and then it would be times the square root of x squared, which is just going to be pi over 2x. So we integrate the area, pi over 2x, and there's our dx. So we end up with a volume is equal to pi over 2 times x squared over 2. We're going to evaluate from 0 to 9. So then we get pi over 4. I put that out front, and then I have 9 squared minus 0 squared, which is, of course, equal to pi. Oh, we could just write that as 81 pi over 4. 81 pi over 4. And I hope this video was helpful with cross-sections perpendicular to the x-axis. So on the next video, we'll talk about cross-sections that are perpendicular to the y-axis, using the same base area with different shapes for cross-sections. Have a nice day, stay healthy, stay safe, and stay positive.